Today we're going to be talking about the equation of a circle, more specifically how to find the center and radius of a circle when the equation is given in standard form, which means we have to complete the square. In order to do this, we're going to be going over two Regents questions, June 2024, question number 29, and June 2022, question number 30. So let's get started. For this first question, it says the equation of a circle is x squared plus y squared plus 8x minus 6y plus 7 equals 0. Determine and state the coordinates of the center and the length of the radius of the circle. So what's really important to first note is how you're going to be graded for this question. You need to show algebraic work. If you just give the center and the radius, they will give you 0 points because it says determine and state. So it wants to see the work along the way. The equation that they gave you, this x squared plus y squared, all this good stuff here, right? That is in standard form. Standard form is essentially when everything is in order with largest exponents, alphabetically, everything's on one side of the equal sign equal to 0, right? However, it is very difficult to pull out the center and the radius when you are in this form. So we need to get into something called center radius form. So let's talk about what that is. So for center radius form, it's actually x minus h squared plus y minus k squared equals r squared. So many letters I know. So let's talk about what those letters are. H and k actually represent the x and the y coordinates of the center of the circle. So that's our center. And you'll notice that if you look into the equation, it says minus h and minus k. That means that when you pull out the h and the k from the equation, or the x value and the y value of the center from the equation, the signs actually change. So that's important to keep in mind. And r is our radius. So in our equation of our circle, our radius is there, but it's actually being squared. So that's really important to remember as well. So now if I can get my standard form into this form, I can easily pull out my center and easily pull out my radius. So let's go ahead and do that. Actually, before we do that, let's just do one quick example. So using this form, this center radius form, if I was to give you an equation of a circle such as this. So if I was to say, for example, x minus 5 squared plus y plus 3 squared equals 16, right? I can now pull out the center and the radius. So my center is going to be the number with the x and with the y. That's my x coordinate of my center and my y coordinate of my center. So this -5 and this +3. But again, I have to change those signs. So when I pull it out, it ends up being +5 and -3. So that would be my center pulled out from this equation. And my radius is going to be the square root of 16, because again, in my equation is going to be actually my radius squared. So I have to take the square root to find it, but we know that 16 squared is 4. So that means I have a radius of 4. Okay, so we're going to use this information to solve question number 30 from the 2024 Regents, okay? We have to complete the square in order to do this, but that form is what my ultimate goal is. So let's review completing the square. First thing I'm going to do is just rewrite my equation to get some room. So x squared plus y squared plus 8x minus 6y plus 7 equals 0. The first thing I want to do is I want to get all my constants out of there. So this plus 7, I want to get rid of. So if you take a look, you see this plus 7 here. I want to do the additive inverse to get that to the opposite side of my equation. So I'm going to subtract 7 from both sides, okay? What that's going to do is it's going to still leave me with my, it's going to leave me with all my variables on the left-hand side, but on the right-hand side, I'm going to have a -7. So these are reduced, okay? Now on the left-hand side, I am going to bring all that down. I'm going to rewrite it, but I'm just going to organize it differently. I'm going to take my x's, so my x squared and my plus 8x, and I'm going to put those together. I'm also going to put my plus y squared and my minus 6y together, okay? So it's kind of like putting them on teams. That's the way I like to think of it. So it's x squared plus 8x, those are together, and then also plus y squared minus 6y are together as well. Now you'll notice that I left some blank spots. because what we're going to be doing here is completing the square, just like we did in Algebra 1. The only difference is I have two different variables, so I'm doing it two different times, okay? But we are going to try to make this left-hand side, the left-hand side, this x squared plus 8x, we're going to try to make that a perfect square trinomial. So we have to think about what we have to add in here to make that happen. Okay, then we're going to try to do the same things with the y's. We're going to try to make this a perfect square trinomial. So we have to think about what we have to add in here to make that happen. Now, what's really important to remember is you just can't add things to one side of an equation. So if you're going to be adding a number in that blue box, and if you're going to be adding a number in that pink box, you need to make sure you're adding that same number to the opposite side of the equation so it remains balanced. Okay, so we're just going to put those boxes there to remind us whatever we add to the left, we add to the right. Now, I want you to think of that center radius form. We know that this is going to be x with some number squared plus y with some number squared, okay? Now, what is that some number? What number belongs in here? Okay, the number that belongs in there, we're going to get from our b term. So that's this guy, okay, this plus 8. In order to get this number, we're going to take this plus 8 and we are going to cut it in half, right? So plus 8 cut in half is plus 4. That sign is really important, okay? So what that means is that if I was to cut that in half, I get x plus 4 squared. And if I was to multiply that out, I actually need this number here, which is going to be 4 squared. I like to think of it as like I made a square and now I have to square the number to get that value. So 4 times 4 is 16. Okay, so what that means, if I was to factor this trinomial here, this one that I just created, right? If I was to factor it, I would get x plus 4 squared. All right, so we just used some tricks to get there. That's all we did. All right, now on the y side, we're going to take that same thing, this b value, this number in front of our middle term here, or a coefficient of our middle term, I should say, and we're going to cut it right in half. So -6 cut in half is -3, right? And remember, to get back to that square over here, we're going to square -3. So that means we're going to do -3 times -3, which is a positive 9. Now, it's really important to note that the boxes are always going to be positive because a positive times a positive is a positive, and a negative times a negative is a positive. So you're never going to get negative numbers in there. So it's looking really good. We're looking like we're getting our center radius form. The only thing we have to do is worry about the right-hand side of the equation. Again, that blue box is a 16 and that pink box is a 9. I'm keeping my equation balanced. So if I add up all those numbers on the right-hand side, I get 18. All right, so now look, we have this in center radius form. All I need to do is pull out my center and my radius. So again, my center and my radius. My center is going to be what's with my x and my y. I'm just going to change the sign. So instead of +4 and -3, it's going to be -4, +3. And my radius is, don't forget, it is not this number over here, right? I haven't used orange. Let's use orange. It's not this number over here. It is the square root of that number. So the square root of 18. Now, it's important to note that the square root of 18 is not a perfect square. The 18 is not a perfect square. So the square root is not a rational number. That means if I was to put rad 18 into my calculator, I would get a decimal. More specifically, I'd get 4.242640 ... It goes on forever, right? I cannot write that decimal. That decimal is not rad 18. It is a truncated version. It is a rounded version. So you are writing the wrong number if you write that decimal. You can simplify rad 18 if you want to. That is also correct if you write it in simplest radical form, but it is not necessary. This is the radius. You are finished. You do not need it in simplest radical form. Okay. For those of you who are curious what it would be in simplest radical form, rad 18, the largest perfect square that fits inside of 18 is 9, right? And it's 9 times 2. And the square root of 9 is 3. So 3 rad 2 would also work for our radius, right? Either one would work, but you do not have to simplify it. All right? So that is completing the square to find the center and the radius. Let's do one more example. So June 2022, determine and state the coordinates of the center and the length of the radius of the circle, whose equation is x squared plus y squared plus 6x equals 6y plus 63. Now I like this one a lot, mainly just because it's a little different. It's a little bit different because we just have things on both sides, which gives us a little bit of an extra step. So again, if I have x squared plus y squared plus 6x equals 6y plus 63, I'm going to divide down this equal sign. My goal is to get my variables, all terms with variables on this side, and my constants, so just my regular numbers on this side. Okay, so let's start by moving my variable. I'm going to subtract 6y from both sides. Okay, because I do not want 6y to exist on this right side. And on my left side, I'm just going to reorganize it so it goes where it belongs. I can't subtract 6y from x squared. I can't subtract it from y squared. I can't subtract it from 6x. So all I can do is just put it right at the end there. I'll reorganize it after, right? So I'm going to write this as x squared plus y squared plus 6x, and I'll just put my minus 6y at the end. And I have equals 63. All right, so now I have all of my variables on the left, all of my constants on the right, all is right with the world again. Now all I'm going to do is I'm going to rearrange my x's and my y's. So I'm going to go ahead and put these on my teams again. This is an x, this is an x, this is a y, this is a y, and I'm going to leave place for those boxes. Okay, I'm just going to zoom in a little bit for us here. So I'm going to write it as x squared plus 6x plus y squared minus 6y, and I'm going to leave the equal 63 over here. All right, so I'm going to put in a box for my x terms on both sides, a box for my y terms on both sides, and now I'm going to work on completing the square. Now, keeping in mind, just to keep myself organized, these x's are going to go to a binomial squared, and these y's are going to go to a binomial squared. Because we know center radius form is x with some number. Let me give myself a little bit more room than that actually. X some number squared plus y with some number squared, right? Now, again, that b term, this middle term, right? And I'm saying b term because I'm thinking of ax squared plus bx plus c. So it's that b term, right? Is going to tell us what goes here. And we are going to cut that right in half, right? So positive 6 cut in half is positive 3. And then to get the square, I'm going to square it. 3 times 3 is 9. And right away, I can put that 9 in my box on the other side as well. Okay. Now I'm going to do the same thing with my y's. I'm looking at that b term. I'm going to cut it right in half. Negative 6 cut in half is negative 3. And then to get the square, I'm going to square it. Negative 3 times negative 3 is 9, right? Always going to be positive. A negative times a negative is a positive, and that's going to go on both sides. Okay, so now what I'm going to do is I'm going to just clean up that right-hand side, and I'm going to say 63 plus 9 is 81. Okay, so now I have my equation in center radius form. So let's go ahead and get that center, and let's go ahead and get that radius. Okay, so my center, again, I'm changing the signs. I'm going to color code this one just so you can see. My x value is going to become negative 3 because the sign changes, and my y value is going to become positive 3 because its sign changes as well. And my radius is going to be not 81, but the square root of 81. Now, the nice thing about this compared to my last example is that is a perfect square. 81 is a perfect square, so the square root is 9. Okay, so let's make sure I answered the question. Determine and state the coordinates of the center and the length of the radius of the circle whose equation is ... And I think we did that. So it's really important to remember that you need to know how to complete the square. This question shows up a lot as part 2s. It's a really nice part 2. But it will give you 0 points if you don't show where that center and that radius came from. So make sure you show all of your algebra for completing the square.